Chapter 22. Reading the Universe. Whatever matter is, it is not made of matter. Matter, as we know, it exists only in the mind. Attributed to physicist Hans Peter Dürr. Thomas Young was a brilliant physician and physicist of the early 19th century who wanted to prove that light was, or at least acted like, a wave. Being a prodigy as a child and a super polymath as an adult, Young believed that light behaved like sound waves or ripples of water in a pond disturbed by a pebble thrown into it. So he devised an experiment to see if this was so. Young used a mirror to direct sunlight through a couple of small holes in a piece of paper that divided the light. When the holes were a specific distance apart, the light reflected showed an interference pattern. An interference pattern is where waves either strengthen or cancel each other out with ebbs and flows, like when one drops two rocks simultaneously into a body of water. Since interference patterns are indicative of waves, light must be a wave. Later, another physicist, George Gabriel Stokes, used a monochromatic light source to observe the interference pattern. So, the various colors of light were not responsible for the effect. Still further, Charles Thomson Rees Wilson fired a beam of electrons at the slits, and they produced the same interference pattern as the light waves. Other subatomic particles were creating the interference pattern. It made the pattern even when single electrons were shot at the slits. The results led scientists to conclude that matter on the smallest scales displayed a particle-wave duality. Then, someone had the idea to measure which slot the particle was going through, thinking this might provide some insight into the interference pattern. Amazingly, when physicists measured each particle to determine the which-way path of the particle, the wave function disappeared. The image on the detector consisted of two clump patterns indicative of individual particles instead of waves. Scientists call this change the wave function collapse, and together pose one of the most profound conundrums in physics. How does measurement make a wave-like object become a particle-like object? This is ubiquitously called the measurement problem of quantum mechanics. Quantum mechanics is the theory of matter at its smallest, and is called quantum because particle waves come in little chunks or quanta. As if this were not esoteric and counterintuitive enough, physicist John Archibald Wheeler, 1978, imagined a thought experiment using the concept of entanglement, and a variation of the double-slit experiment he hypothesized might yield insight into the measurement problem. Entanglement is where two particles seem to affect each other at a distance, but I will return to this later. In the thought experiment, Wheeler imagined that the measurement could be split and manipulated between two entangled particles, so the way path information is inferred from the setup rather than directly measured. The idea aimed to eliminate the chance that the act of measurement using detectors collapses the wave function. The experiment is named Delayed Choice Quantum Eraser because the choice to measure was postponed until the particles passed through the two slits. As a result, certain waypath information was erased by the 50/50th chance of prisms comparing particles between known and unknown paths. It appeared that nature was not fooled when the experiment was performed in the lab, 1999. The experiment resulted in clump patterns when the waypath information was merely inferred by the setup and an interference pattern when the waypath was unknowable. It was as if the particle knew what the observer knew and acted accordingly. The appearance of the clump or interference pattern conformed to the contingency of knowing the way path, even if it was not directly measured. We learn from quantum mechanics that the wave function collapses when an observer, or even some mechanical device, records information, whether directly or inferred. If any specific information was recorded or transferred, the wave of potentiality becomes actuality. Reading causes what is read. So, theoretically, when no one is looking at the moon, it does not exist, and a tree does not make a sound if no one is there to hear it. A story only creates images in the mind once it is read, but without imaginative choice, there is no story in the first place. This seeming paradox is analogous to what quantum theory says about the particle. A particle acts as a wave of probability until it is measured, making specific information known, but it was not there before measurement. The act of knowing and creating the object of knowledge is idealism. The story is incomplete or unactualized if you don't perceive the words, but they are only possibilities until you perceive them, and round one goes. Since Albert Einstein, physicists have known the interchangeability of energy and matter. For example, the famous E equals sign, Mach 2. So perhaps the material world is better defined as energy. Yet this makes the necessity of the mind even more vital, because anyone who studies the definition of energy will find only mental abstractions. So the agnostic physicist will not find solace here. This subplot in our story is clouded by technicalities, esoteric mathematics, and science, so it is necessary to delineate standard definitions. What is energy? Most high school textbooks give the short answer that energy is the capacity to do work. That is undoubtedly unhelpful if all of matter is the abstract capacity for work. That is like saying all words are verbs. What does that mean? It begs the question, even if we interpret capacity for work as the potential for being. So, energy is the potential for a thing to be so. That would mean everything is only potentially everything. In homage to the venerable Forrest Gump, we then say, energy is as energy does. Fortunately, or unfortunately for the materialist, physicists have two more precise definitions of energy. The first is that energy is the property of motion of which any measurement is conserved, that is, does not change over time. Here, energy is more like an adverb. It describes what a verb is like. However, this definition of energy is an equivocation. For example, take the phrase, "The rabbit is hopping energetically." Does this mean that energetically is a property of hopping or the rabbit? Grammatically, it describes hopping, the action. But if energy defines the physical world, vigorously would refer to the subject, the rabbit. Energetically is not a property of the rabbit, since a rabbit can be asleep, paralyzed, or dead. The same variance is true of energy. This logical trajectory is problematic because potential energy, a manifestation of energy, does not move. Mass, equivalent to energy, that is, E equals sign Mach 2, does not need motion as a property. Instead, mass inhibits motion. Moreover, motion is a change in progressive location within a relative field. Consequently, defining matter as anything with a moving property does not intrinsically tell anyone what a thing is, especially when a thing also has mass and therefore resists motion. So, physicists have an even more abstruse definition of energy as the interaction between and motion of fields. Energy, then, is seen as an excitation or permutation to a field. This definition is better, if only slightly less circular. If energy causes these permutations, waves in the field, then energy is still undefined, because the cause is separate from its effect. As a particular thing, energy would affect the field and cannot be defined by it. This distinction is essential and is not entirely clear by the language physicists use. For example, many physicists will say a field is constantly moving or excited because the energy is never zero, that is, it has energy. Does this mean that the field defines energy or that the field is affected by energy? The former would mean that energy is just a property of a field, and all the applications of energy in the physical world are essentially fields. If the latter is true, energy is independent of a field, and therefore undefined. The former would imply that fields move by their very nature, so that all matter and energy are manifestations of this ambiguous field. So, we need to ontologically define this fundamental thing called fields if we hope to grasp what anything is. What is a field? The field concept is what makes O'Dowd's worldlines conceivable. A field in physics is something that takes a value at every point in space-time. For example, if you imagine sitting in a room, the temperature would be analogous to a field. It is a frame of reference with measurable values at any point in the field. For example, the temperature near the heater vent is higher than the temperature on the floor. Still, the values share the common temperature field, hardly what anyone would call physical at this point. So we continue. The fields that physicists talk about are particle fields. So, there is a proton field, an electron field, and a Higgs boson field. Each is like a body of water with waves. The taller the waves, the more energy they have, and vice versa. The height of these waves is limited to discrete amounts rather than fractions. Furthermore, these fields are always everywhere, like the Force in the movie Star Wars. It surrounds us and penetrates us. It binds the galaxy together. Physicists insist in a contradictory manner that these fields are real, that is, physical, because they exist connected to space and energy. Are fields fundamentally physical or material, separate from thoughts? Materialists beg the question of whether this merely means that fields are physical because they have energy and space properties, when energy and space are presumed to be ontologically independent of the mind. On the surface, fields, with their concomitant manifestation of space and energy, are mental in nature. It is hard to deny they are mental constructs when their description is wholly mathematical in nature. Is the fundamental ground of the physical world unmental if they are intrinsically mathematical? Isn't math a mental construct? They affirm the physicalness of the fields, even though a field has no apparent substance. It is not made of anything. How is this not causing cognitive dissonance within them when the material is defined solely as mental constructs? However, as just noted, a field is linked to space and energy, but space and energy are defined in terms of a field, making their definition circular. What is energy? It is excitations, differences, in a field. What is a field? It is that which has energetic values at any point in space. What is matter? It is the summary of all permutations in the fields when the wave function collapses from measurement, and according to Einstein's theory, mass is energy. What can we safely conclude about the ontology of the physical or the material world? According to physicists, at least anything measurable is physical. But what of the measurement problem? Particles have no independent existence apart from the measurement, and all measurements excite a field of possible values, measurement, at every point in space. Hence, that which is measurable is only measurable the moment it is measured. So, combining this reduction of the particle-wave duality, we stumble upon a bizarre tautology. The physical is any measurement of a field of measurements. Replace the word measure with the word perceived, and you see that the physical world is sensing a field of perceptions. Yet, putting these ideas together is like making a house out of water. Others define one definition that reflects the first, like journalists quoting each other for their sources. Some use definitions slightly nuanced in ways to avoid cognitive dissonance carefully, but every description is qualified so that, as you may have already concluded, it becomes too esoteric, too jumbled. One thing is for sure, though, quantum mechanics has yet to strengthen the materialist worldview. Nonetheless, I conclude that the bottom line of all these permutations of definition, circular logic, and vague mathematical constructs is that, for the agnostic physicist at least, anything physical is anything measurable, so all things that truly exist are only physical because they are measurable. This is the spirit of empiricism, but is this not the very essence of esse est percipi?